A robotics video went viral, and the moment engineers saw it, they knew something bigger was happening. A humanoid robot walks through a room, scanning with LiDAR and cameras, completely normal, but the system behind it was turning everything the robot saw into a structured memory of the world. Here's the problem with every robot before this. They live in the present moment. Sensors fire, map updates, robot moves. Context from 2 minutes ago? Ask it where you left your keys last night, and it has absolutely nothing. This capability came from OpenClaw, the open source framework that lets language models actually execute tasks, not generate text about tasks, actually do them. Developers called it giving AI systems hands. Now those hands are moving into physical robots. The timeline is wild. November 2025, Claude launches. January, a trademark dispute forces a rename to OpenClaw. February, it hits 100,000 GitHub stars. Valentine's Day, the creator joins OpenAI. By March, 200,000 stars and a foundation. Stash Pomictor and the Dimensional team added something called Spatial Agent Memory on top of OpenClaw. The robot connects place, object, and time. Where things are, where people move, and when events happen. Stored in a persistent model, the robot can query like a database. They solved the data problem with voxelization. Imagine dividing physical space into tiny 3D cubes called voxels, like three-dimensional pixels. Each voxel stores a vector embedding for its geometry and a semantic label for its meaning. Stack them up, and you get rooms, objects, surfaces, and timestamps. That's the robot's spatial memory. Here's how the pipeline works. LiDAR and cameras feed raw sensor data into a voxel grid. That grid maps into a spatial vector store. A query engine translates natural language into searches across objects, rooms, geometry, and time. The LLM reasons over the results and answers. This is what makes the demo feel different. You're not scrubbing through security camera footage, you're running queries. Where are the keys? The system searches by object label. Who came in Tuesday evening? It scans movement patterns. This is a structured model of the world, not a recording of it. In code, it looks like this. You set the voxel resolution. 5 centimeters is typical. And the robot ingests every LiDAR frame and camera frame as it moves. Then you query in plain English. It returns the location, timestamp, and confidence score. Time-based queries work too. Within hours of the demo, engineers were sharing it and debating what it means. Some called it the spatial memory milestone robotics has needed for decades. Others joked that someone had basically open-sourced Skynet on GitHub. OpenClaw now supports 80% of Chinese OEM robots and has over 3,000 community skills. OpenClaw doesn't replace ROS. It sits above it. ROS has 15 years of low-level hardware control. OpenClaw adds the intelligence layer, natural language commands, LLM reasoning, hardware-agnostic architecture. ROSClaw, which won the SF OpenClaw Hackathon, builds a bridge between both worlds. The Unitree G1 Experiment made this concrete. $16,000 of humanoid robot with 3D LiDAR, depth cameras, and advanced joint mobility, controlled entirely through text messages. Forward 1 meter, turn left 45 degrees. The robot executes. Send photo, and it snapshots the room and sends it back. The OpenClaw Unitree robot skill handles the full translation. The agent receives a message, plans the movement using the language model, and calls the locomotion executor. Camera captures come back through the same messaging channel. No robotics. SDK knowledge required from the user side. The Unitree G1 is just the start. A 16-joint 3D printed hand called Arrow Hand Open was calibrated via a USB camera. The AI generated servo commands and narrated every gesture through Telegram. A 7-axis robotic arm was controlled using nothing but natural language, generating Python kinematics code on the fly. Experienced robotics engineers are quick to point out what a lab demo hides. Sensors conflict. Lighting changes break detection. Objects move and the voxel map goes stale. And there's a real concern: the LLM reasoning layer can't move as fast as motors need to react. The developers address this with a clean separation. Real-time movement stays with the robot's own control system. Motors, joints, locomotion all run at full speed. OpenClaw sits above that as a high-level coordination layer. It observes, builds memory, and decides what action should happen next. Fast body, slow mind, by design. Ben Goertzel at SingularityNet went further with QwestorClaw, pairing OpenClaw's execution power with a dedicated cognitive layer called Questor. Questor handles episodic memory, goal-driven planning, and progressive reasoning. Capability tokens define exactly what tools OpenClaw can access and for how long. External inputs enter quarantine before touching trusted memory. Which brings us to Goertzel's framing. OpenClaw is an amazing set of hands for an artificial brain. What it doesn't yet provide is the deeper reasoning that would qualify as AGI. Impressive behavior, without solving the deeper cognitive challenge. The end game is peaq's vision: robots with decentralized identities, holding funds, executing transactions, participating in machine-to-machine payments. The machine economy. 2026 is looking like the year AI agents start interacting directly with physical reality. The hands are here. The brain is coming.